to everybody, and let us start with where we left day. Uh, Screen also, so no problem.
Yes,
Anybody?
son.
Okay.
Yes, sir.
So let's straight away move to that. I will open it. Okay, it's taking time. Okay, that's all. Yeah. Yeah. So you can see, so we have created the model in all respect, uh, and then now we will be going for applying the loading. Now, definitely the loading will consist of primary load cases. So the theme that ETAB is following that in one thing, it will create the load patterns. So the type of loading will be decided by load patterns, and under that load patterns, we'll be creating additional that is a load quantity, and that will appear in load cases. So to define the type, we'll have to go to define, then click on load patterns, and as you know that dead and live are already there, and we need one more additional load, and that will be STL. Okay, so the type will be super dead, multiplier will be 0, and you will add it. Okay, so for gravity loading, uh, dead, which we will be using for SAPWET, and live will be used for live load, and STL will be used for all other dead loads which are permanently acting on them. Okay, so the three load patterns are sufficient. So we'll close this, and we'll see how to apply the loads. Now, okay, we'll start with let's say we'll go to terrace, or we can go to first. Okay. Okay, so we'll be going to first, and under first, what are the different loads that you will be applying? So self weight, you don't have to worry. Then STL will be in terms of for STL, you will see that for bathroom, which is for some different sunk, then there will be any other balcony, etc. It will have some different sunk, and uh, floor finish. Okay, so you can say that this is for floor finish. So for floor finish, you will follow your IS 87 part 1, that is dead load. And live load, again, you can find out that through IS 87 part 2. Clear? So how you will define it? So that means we have to add it. So let us start with the condition that say if I select this. So if I go to similar story option, and if I select this, mm, it's something. You can see this is the selection, and if I go over here, this is the selection. Okay, so that is correct. So similar story option is on, and you can check it over here. And let's select this. Okay, so for this, you can see three shells are selected. That means you are selecting at first story, third story, and fifth story. So similarly, you can select this 1, 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11, and 12. Let's say all these are uh, residential premises. So living, kitchen, and bed. So all these will have live load intensity of 2 kilonewton, and that you can get it from IS 875. So after selecting, you will go to assign, and in assign, as you have selected the uh, surface elements, so that is cell element, and under that you will go to uniform. So that uniform, then type here as live load, and then you can press and check out that quantity or magnitude that you are putting is 2.0. So let me do it 2.0, and then you can see replace existing load, direction is gravity, and you can apply. So that you can check it over here. So it has been applied everywhere. Now all these are also a normal slab. That means there will be floor finish. Now it is up to you. So whatever floor finish that you are calculating, let's say it is 1.5. Normally it will be something around from 1.25 to 1.5 for normal slab. So that's why I will again go to this select, click on that, and get previous selection. So all selection that is available, and here you will choose STL, and under that you will say 1.5. Clear? Yes. Now you
Yes,
can
sir.
check it. Now you can check it that you have applied live load equal to 2 and STL equal to 1.5. Similarly, you can consider this as passage. And so for passage, you will see that 1, 2, 3, only three cells are selected, and you can go to assign, then shell load. Under uniform, you will see that again go for live load, and live load that we are going to consider is 3.0. Apply. Similarly, I will select it again, and I will apply STL, which is again equal to 1.5. Okay. Now this is about bathroom. So for bathroom, I will say 1, 2, 3, and 4. So four toilets or bathroom areas we have selected, and in that case, we'll be applying live load equal to 2. So go to assign, shell load, uniform, and under that you will say that live load, and it will be around 2.0. Again, as numbers were more, so I can either go to clicking over here, or I can go straight away, select, and get previous selection. So the previous selection will be available, and then I will go for STL. And now this is the STL that you have to calculate. And how you can calculate? Okay, for this, let's say I will pull this. I will go to that. We'll find out that drawing. So in that, under this double practical problem, So the drawing will see that, because we want to find out the sunk, and that sunk is, I think, it is something around 325. So based on that, you will have to calculate the sunk load. Over here. So this is the sunken part, and you can see under that on the toilet sunk, that we are considering as 0.325. So what will be the loading? So 0.325 will be its thickness multiplied by density, that is I'm considering as 20, and that will be the loading due to the sunk part. Okay, so how much it is? Hello, 325 means it will be 650. That means into 20. Yeah, 6500 and this. So it will be 6.5 kilonewton per square meter. Then additional loading for floor finish, that is plaster and etc. If you consider it as 1.5, and you need not be very accurate, because it's all approximate. So something 1 kilonewton, a little bit difference here or there, that is okay. So finally it will be something around 8 kilonewton per square meter as your sunk load. Okay. Yes.
Yes, sir.
Yeah. So we'll go to our model. Then we'll remove this and we'll put it over here as 8, 8.0. That is your STL that is applied on bathroom. Clear? Now about staircase. Again, staircase thickness, you don't have to worry about it. Then you will have to go for that calculation that you will have to see. See, this is your going. This is the thickness of your west slab, and that you have considered something around 200. But the calculation of this dead load is not required, because we have modeled this. So this inclined portion we have modeled, and what we have not modeled is the portion of this. Yes. Hello. Clear?
Yes, sir.
So this portion will be the weight that is not considered while drawing the slab. That's why you have to add it, and that will be, if you consider this as your R, that is riser. Okay, and you can see that the riser, uh, you will apply it like this. Load due to riser into 25, where R you consider in meters, or you may say that if you are considering R equal to say 150, then you will calculate it as 150 divided by 100, or R in meters, whatever. So that load is calculated. Then there will be additional flooring over here. Then there will be another riser over here. So that also you can apply. Then you may consider a thick plaster that is applied over here, right? So you may calculate this. So all that, if you calculate it, it will be something around, I think it is something around 5 or 5.5. So you may safely go for 5.5 kilonewton per meter square, right? Yes. So that will be your STL, and live load, that you will see that will be something around 3 kilonewton. So all this you will add on the loading for staircase. So, okay, the some percent here or there. I will say that for residential loading, total load, including the self weight of west slab, then that triangular part, then live load, all that is for your information. I will say that it is something around 12 to 15. It is in the range 12 to 15 kilonewton per square meter. Okay, and that will include dead load due to self weight, then floor finish or STL, that is due to all that triangular part and that, and live load. So all together, you will see that it, for residential conditions, it this is the maximum range. So anything in this range is okay. That uh, it will your results will not affect much if you are in this range. This is minimum and this is maximum. Because all this depends on uh, whatever depth that you are considering. Normally the depth of slab is depth of west slab is from 140 to 200 for residential. Again, I am talking these ranges for residential. If you are going to commercial with a very large span, etc., it may go up to 250 or sometimes 300 also. So accordingly, this value will get changed. But finally, for your rough judgment, I will say that it should be in this range, 12 to 15 kilonewton per square meter. That will include self weight, STL, and live load. Clear?
Yes, sir.
Yeah. So that is the range that I am giving, and anything in between that is okay. Uh, so what we will do, we will click on the staircase, and you can see again 3 staircases have been considered. Then you will go to that. The, the process is same. Shell load, uniform. Under uniform, first you will go for live load, and the live load will be something around 3, and then okay, and then again 1. Yeah. Again you will, then you will go that, and it is something around 5 or 5.5, let's say 5.5. And if you want to find exact calculations, and if you are very much worried about whether it is 5.5 or 5.75 or 4.25 or all that, you will give you the input DBR, and we'll be discussing that. But right now I am assuming it as 5.5 and clicking on it is okay. Clear? Yes. So is there anything that is left? Nothing. You can see 2 and 8. Then you can see over here 3 and 5.5. Then here it is 2 and 1.5. So similarly, we'll go to one step ahead, and there again we'll repeat that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 into 2, 24. So you can check it, 24. That means only the terrace floor is remaining. Then go to assign, go to shell load, uniform, and under that live load, and it will be do and replace and apply. Then again you will go to select, then get previous selection and go to STL, and it will be 1.5 as usual. So whatever that you have done earlier. Okay, now you can check this. So click on that, go to assign, shell load, uniform, live, and now the live load will be 3 because it is passage, and replace, it is okay. Then again I will select it, go to assign, shell load, uniform, and STL, and it will be 1. Yeah, 1.5, that is okay, and apply. Okay, then again I will this, okay. Now I will select 1, 2, 3, 4, and then go to assign, go to shell load, uniform, and then live load, and live load that we have applied as 2. So apply, then select, get previous selection, make it STL, and under STL category we'll apply the load of 8 kilonewton because that is 325 sunk, and apply. Okay, now this is the part. So I will select this, I will go to assign, under that shell load, uniform, then live, and then 3, and apply. Again this, then STL, and then the quantity is 5.5. Apply, and okay. Now except balconies, everything that you have considered. Now select the balcony, 1, 2, 3, 4. So when you have selected the balconies and check it that 4 into 2 has to be 8. So only 8 are selected. And in that, go to assign, go to shell load, uniform. Now here it is your choice. If you consider this balcony as subjected to overloading or overcrowding, you may go for 3. Otherwise, you may go for a live load equal to 2. Okay, so I'm going on higher side. Let us see. I don't know whether people will gather over there or what. So I will consider maximum as per codal provision. So maximum is 3, and apply. Now again, click over here and check check the sunk part. So the sunk part for bathroom. So what is that? Balcony sunk is 150. Okay. So how much sunk I will have to consider? So I will first go to select, get previous selection, and under that I will go STL, and 150 multiplied by 20. So that will be 3 kilonewton. Then plaster and tiling, etc. If I calculate that, then it will be 3 plus 1.5. So at the most 4.5. Right? Apply. Any doubt over this? Hello?
No, sir.
Okay. Then straightway I will go to terrace. Okay. And at terrace, now now it is up to you whether you are going to provide a waterproofing on the terrace that is of 100 thick. Then you will have to add uh, load due to waterproofing as STL. And if you consider this entire terrace as a subjected to overcrowding, so you can say that for overcrowding, now you can check it 3 plus 3, 6, and 6, 12, and only 12. So even if the similar option is there, as this floor is not similar to any other, you are getting only the 12, the magnitude or total number of slab that you have clicked manually. Okay, so you can consider this entire subjected to overcrowding and this also, and then for residential buildings subjected to overcrowding, live load will be equal to how much? Yes,
Okay.
3.
Three.
Yeah. कोड जितना जल्दी आप कोडल प्रोविजन पढ़ लेंगे उतना अच्छा रहेगा. No doubt will be giving you that all important notes, but it is good to go through the codal provision. Okay, so the live load now for normal residential building, if you are going for terrace, code says that when the terrace is accessible, you may consider live load equal to 2, and when the terrace is not accessible, that means you are not providing any uh, vertical going over there, means the terrace is not connected with the staircase, then it will be inaccessible. That is called a roof. In that case, we don't call it terrace, we call it roof. So in that case, if the roof is not accessible, then code says that you may consider 1.5 as a live load. But if it is accessible, then it should be considered a 2. That is what code says. But code does not say whether the terrace is subjected to overcrowding or not. So you can have that under the balconies. Code always say that when the balconies are subjected to overcrowding, you may go for live load equal to 3. So we are going on higher side. Clear?
Yes, sir.
Okay. So the 3 is applied, and now you can go to STL and you can select
एक्सक्यूज मी
that
सर.
previous. Yeah.
सर जो आप बता रहे हो ये वाली चीज टेरेस सर, ये कौन से मतलब कोड में 456 में तो ये चीज नहीं है सर, और कोई कोड में है?
अरे तो मैं इतने बार क्या बताया, IS 875 पार्ट 1 फॉर डेड लोड, IS 875 फॉर पार्ट 2 फॉर लाइव लोड. अगर आपको डेड लोड कैलकुलेट करना है, ओके, आर यू गेटिंग माय पॉइंट?
यस सर.
If you are going for estimation, what is the codal direction or what is the codal guidelines that are to be see the first thing is that you have to judge on yourself. First thing, based on the client requirement, based on your experience, and based on whatever may be the maximum loading that you can consider. Okay, but if
Okay,
you are not enough having enough experience to judge it correctly, then code has given you guideline, so you can follow that guideline. And it is always better to follow the codal guidelines. So the guidelines for dead load are given by IS 875 part 1. Okay,
ओके सर.
then guideline for live load that are given in IS 875 part 2. Then guidelines for lateral loads, that is maybe due to earthquake and etc. So they are given in part 3, IS 875 part 3. Then for wind, IS 875 part I think 4, and there are 5 parts. So you can go through that, and you can read. All that is given to you. Otherwise, you can prepare your guidelines, but those guidelines shall not be less. See, if you are considering live load equal to 5, then what will happen? You will be on conservative side, but you will be safe. Code says that you should not go for uh, a loading which will result on unsafe side. Clear?
यस सर.
Yeah.
सर कोड सेफ्टी भी बताता है, इकोनॉमिकल भी बता देगा.
Economy is not the see, code says what we are going through n number of observations and data, and after analyzing all that data, we say that under normal conditions this will be the total load. But if the abnormal conditions are there, then you have to judge. But see, what economy is not a part that code should consider. Economy is a part that depends from person to person, individual to individual, as well as money that you are having. Barabar. So I will say that code will give you guideline for safety, and not only safety but reliable values which are very close to exact, and the percentage of getting exceeding that value will be not more than 5%. Clear?
यस सर.
मान लो ओके, मान लो कि अगर मैंने यहाँ पे इंस्टेड ऑफ 3 मैंने यहाँ पे 1.5 लिया. Okay, so
Okay.
what is the probability of that load getting exceeded in the lifetime of that building? That means maybe you are considering 50 years. So what will be the probability? So code has gone through that, and under various observations, they say that probability of this load exceeding will not be more than 5%. So under 95% time, out of so for 50 years, your answer will be safe, and that safe accuracy is up to 95%. तो रिस्क तो हर चीज में होती है, क्योंकि आगे क्या होने वाला है, नोबडी कैन स्पेसिफाई इट विद गारंटी. हाँ, आप लोग प्रेडिक्ट कर सकते हैं ना, सही है कि नहीं?
यस सर.
कल क्या हो सकता है, इसका कोई गारंटी के साथ आंसर देगा क्या? नहीं. तो प्रोबेबिलिटी है. So we are talking about the probability of occurrence, and that is what code has given you a guideline based on n number of empirical data analysis and probability theory applied and total reversal conditions. There are n number of things available. So we are getting ready-made answers. Otherwise आप खुद कर लो ना, बराबर है? Clear हुआ?
Yes sir.
Okay, so where were we? So we have selected, and now we have applied, I think, live load, and we want to apply superimpose dead load. So we'll go to that uniform under live. Now I will go to STL, and under STL, let's say for this STL of waterproofing as 150. So it will be 0.15 into 20. So it will be 3 plus 1.25. That is for plaster and tiling or etc. So I will go for 4.25. Okay. So the load under live load, a dead load, the superimposed dead load category, I am providing on the terrace as 4.25 and apply. Then I will choose this. So this is my share. So live load will be 3. I will apply, and then again I will choose and go for STL. And how much SDL we have considered? 5.5. Clear? So the application of all these loads is clear. Let me show you the papers and that we will be giving it to you also. So see, this is the document that we have developed for you. So this DBR practical, let me click on it. So this file will provide, or I think it might have provided on the classroom.
Yes, sir.
Yes, sir.
Yeah, it has been provided. So
Yes,
civil
sir.
and structural work, design basis report, and that is practical P+5 residential building. So here you will get entire theory, how we are going with that. So this is a design basis, and you can prepare this a design basis report on this guideline. The only thing that uh, things will change, because you can apply it for another model also, and how it is calculated, that has been given over here. You can check it. So I will just show, but I will not go into the details, because the details are very simple, and if you go through this, you will understand each and everything. And if you don't understand, then you can raise the queries, and we'll talk on this. But I will not go with entire, because it is just, you can see, it is very simple, and where from it is, we are finding everything has been given over here. So dead load. So how the superimposed dead load is calculated. Now here you can see weight of 150 mm brick wall. So we'll go into that. We'll see floor finish in living kitchen. You can find out how it has been calculated. So it is calculated as 1.5, and you will get it here. So here IS 875 part 1. Okay. तो अब आपके जहन में ये क्वेरीज नहीं होगा कि वो कहां से लेना है. Clear? So you can see how the toilet sunk has been calculated. Here it has been calculated as 8, right? Hello.
Yes, sir.
Yeah, the picture is also shown so that there will be no misunderstanding. And you can see here balcony sunk has been considered, and sunk load is calculated as 3, and this as this 1.5, so total will be 4.5. Then staircase, see here how the staircase load has been calculated, and you can see here it has been calculated for floor finish load of steps R by 2 into 25, where R equal to 180, that means 0.18 meter. So it has been calculated. It has been calculated as 3.75. Okay, we have considered here as 5.5, but that is okay. It shall not be less than this. Okay, you can see here the calculation has been shown. Then terrace. Now here you can see the terrace load, waterproofing of 120 thick. So here they have considered as 120 thick. So I'm considering waterproofing as 100 thick. तो वो इतना छोटा मोटा वेरिएशन चलता है, because that depends on what procedure that you are applying. Okay, so you can check it. So if you are going for waterproofing of 120 thick, then it will be 0.120 multiplied by 20, so 2.4, plus floor finish of 50 thick, and it has been considered as 1.2, so 2.4 and 1.2 together it will be 3.6. I think we have considered here as 4.25. That is okay. And see, this is very important. If you want to see any guideline for as per our codal provision for steel, it is IS 1786. If you want for plain cement concrete, then it is IS 875 part 1 for dead load, and reinforced concrete IS 875 part 1. Even the pages also we have given for your reference. Brickwork calculation, water calculation, or weight of water. So dead load calculation, you can see all these steel, then plain cement concrete, reinforced cement concrete, brickwork, water, cement cluster, soil. Once it is placed on your structure, it will be always there. So that's why I will consider entire thing as a dead load. And in that case, you can see refer IS 875 part 1. Right? Or that has been shown here also. So IS 875 part 1. Okay. So you can go through this.
Sir,
Yeah.
sir, if we provide water tank, then how will it consider in design and analysis?
See, that is either you can apply the weight of water tank on the columns that are sharing the water tank load, or you can model the water tank. That can be done. पहले इतना तो समझ लीजिए, बाकी तो बाद में देखते हैं ना.
Okay, sir.
See what I will advise all of you that whenever you are learning something, try to focus on what you are learning right now. होता है क्या, सामने कुछ और चल रहा है, हमारे दिमाग में कुछ और चल रहा है, तो जो सामने हो रहा है ना उस पर फोकस नहीं होता है. राइट? when we will be dealing with water tank, we'll talk about it. क्लियर?
Okay.
नहीं, मुझे कोई प्रॉब्लम नहीं है, मगर आपका कंसंट्रेशन कम हो जाएगा, बिकॉज इन योर माइंड यू आर थिंकिंग अबाउट वाटर टैंक. सो वट एवर आई एम राइट नाउ डिलीवरिंग यू विल बी मिस बाय यू. समझ में आ रही है ना बात? धोखा कहाँ पे है? मुझे कोई प्रॉब्लम नहीं है, धोखा आपको है, क्योंकि फिजिकली यू आर हियर बट मेंटली यू आर समवेयर इन दैट वाटर टैंक. So don't do that. Okay, let me show you that also so that you will get it. Okay, so here we have not included water tank, so that we'll talk. But don't worry, हम लोग वो सारी चीजें देख लेंगे. The only thing is that the time has not come for that. तो हम लोग पहले इन प्राइमरी चीजों से बाहर आएंगे और फिर वाटर टैंक के बारे में सोचेंगे. बाकी कुछ नहीं है, वो सारा सिंपल. यू जस्ट हैव टू फाइंड आउट व्हाट इज द टोटल लोड दैट वाटर टैंक इज कैरिंग, एंड दैट टोटल लोड is supported by how many columns. Let's say there are 4 columns, 6 columns, 10 columns that are supporting your water tank. Then you will divide the total load on the columns which are carrying that water tank. That's all. और क्या है? Okay, so this is a very important document, and we have made it very simple for all of you. And I will say that you go through all these 1 to 31. So 31 pages are there, and you go from 1 to 31, and you will find it very helpful for your early लर्निंग फेज. बाद में आपको ये सारा इजी लगेगा, आप बोलेंगे इसकी कोई जरूरत नहीं, अभी हमारे दिमाग में पूरा हो चुका है रिकॉर्डेड, जैसे हम लोगों के है. तो मैं ये नहीं कहूंगा कि ये बहुत बहुत कुछ आइंस्टाइन ने जैसे कुछ निकाला है, तो इट्स नॉट, इट्स अ वेरी सिंपल, बट बेसिक is very very important always. Okay, so we'll be looking in this. Now we are going for calculation of weight of 150 bb masonry. You can see that floor to floor height minus beam depth, so 3 minus 0.45, because we have considered depth of beam as 450. So floor to floor height minus 450, so the height of the wall coming out to be 2.55. And how the self weight is calculated? So this is thickness, this is density, and this is height, and that's why it is coming in kilonewton meter. I think we have discussed it, or shall I explain it again? Not necessary, I think. Yes. Am I audible to all of you?
No, sir.
Sir.
तो आप बात क्यों नहीं करते हैं भैया? मैं कैसे समझूं? Okay. Is it required that you want to see how it has come to be in UDL? Hello.
Yes, sir.
Yeah. चाहिए?
No, sir.
See, finally, you can see. I will just explain it. See, this is your wall. Let's say this is your wall. So finally, this wall will have some weight. That will be W. Okay. So that this weight you can calculate by multiplying thickness by height by length. Yes. Multiplied by density. So I will say that density or specific weight. I will say specific weight. So that is a specific weight, which is equal to 20 kilonewton, 20 kilonewton per cubic meter, multiplied by thickness, that is in meter, multiplied by H, that is also in meter, multiplied by L, that is also in meters. So this 1, 2, 3 will get cancelled and you will get only kilonewton. So that will be total weight. Now, if this total weight is to be distributed over this entire length, so I will have to divide it by L. Then it will come out to be kilonewton per meter. Yes?
Yes, sir.
So that's why we are not counting this length. Length of the beam we are not calculating or counting. We are counting thickness and height multiplied by density. Clear?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So this is thickness, this is density, and this is height. That's why you are getting 7.65 as kilonewton per meter. But where it will be applied? Where you will have the height of wall as 2.55. Now what will happen if the height of, see, we are not changing thickness. Now once you are using 1 bb masonry having 20 kilonewton per cubic meter, you are not going to change the density. Clear? Yes or no?
Yes, sir.
Sir.
So the variable will be height, and that height will be determined in your drawing. Clear? Hello.
Yes, sir.
So I will say that, see, this much unit that I am getting is equal to 3 kilonewton. per square meter. Yes. 0.15 multiplied by 20 kilonewton per cubic meter. I am getting 3 kilonewton per square meter. Yes.
Yes, sir.
So this will be constant every time. Whenever the thickness is not changing, this will be constant. The only thing, the weight of wall will change, and it will be 2.55. So this height will get changed. Maybe sometimes it may be 1 meter, sometimes it may be 2.55. So most of the time it will be 2.55, but under parapet and balcony, you will see that here we are going to have height of wall as 1 meter, right? So that way we can change the SDL. Then you can see plaster. So the plaster is also applied, and you will see that plaster internal and external. So you can find out 9.31 as weight of internal, weight of 150 thick BB masonry having floor to floor height up to depth of beam. So you can apply that 9.31 to everywhere. Yes. Is it clear?
Yes, sir.
So let us go over here, and now you can okay, right now just I will go to this and clear display of assign clear display of assign. Why? Yeah, I will have to go to assign clear display of assign. So this was highlighted, and that's why this was not going. So check it that this is highlighted, and then you can operate. So anything, whatever you are doing, will be reflected in your active window only. So and if this is removed, and that is what I'm talking about, display. Okay, so that has been removed. Now for certain conditions, let's say I don't want to see this this slab. So slab at every floor, I don't want to see. So what I will do, I will go to view, and then I will go to set display options. Under display options, I will say that floors. I don't want floors to be visible. So floors will be there, but they will not be shown, and they will be shown in second window, but they will not be shown in this window. So I will make it not apply to all windows, apply to only one window, which is highlighted. So I will say apply and close. Why it is not applied? Let me see. View, set display options, and yeah, floors. I have to clear this and apply and close. Okay. Now there is, but now you cannot select it, because you can select only those elements which are visible. Here, yeah, you don't have the visibility is not there, so the selection will also be not there. So let us first go plan options and first go to plinth level. So what about plinth? Now you have to see the architectural drawing. So this is your plinth. You can see the architect has drawn a wall over here, a wall over here, and a wall over here. But the height of this wall, and this wall will be different. And you can check it over here. Yes. So on this plinth level, so on this beam, okay, on this beam, there the height of wall will be half. Whatever is mid landing, there will be half. And any other beam, you will see that for plinth level, as there is parking, here it is parking. So there is no wall, right? So depending on that, whether you can apply the loading on this or not is up to you. So depending on that, sometimes you may say that, sir, there might be a wall of say 1 feet or maybe 2 feet. So that wall may be there. So you can apply that loading on the plain beams, and on this you will have to apply full wall load, and on this beam you have to apply 50% height of the wall, so 50% wall load. So the first thing that you have to calculate it, the loading, and the loading that we have calculated is 9.31. Okay, so that was something 9.31. So I will apply that load on say this beam where it is somewhere. Let's say this is a parking. So this part, and in this part, I will apply half of this, right? So for half of this, you may say 9.30. So 4.65. Clear? Yes.
Yes, sir.
Okay. So I will go back to our ETAP model. Now I will select this beam. So after selecting this beam, you can check that only 2 beams are selected. That means even similar story option is on. As the plinth is not similar to anybody, so you are having only 2 selections. So then go to assign. Now don't go to shell load. Now you have to go to frame load because you have selected frame. Go to distributed. Under that, here you will click the STL and check that everything over here is 0, and see that here you are applying that load, that whatever you have calculated, and we have calculated is at 9.31. So I will apply it. Then I will select this, and again I will apply under frame loads distributed, and this much will be something around 3 point, 4.65. Okay. So this is the loading that you can expect at ground. Okay. So if you go one step up, now you have to again check your architectural drawing, and in that architectural drawing you can see that all these beams, every beam except this beam is subjected to load of 9.31. Yes. Hello.
Yes, sir.
Some of you may say that here, sir, this is the this is the uh, this is the portion where there is no loading. Yes. हाँ या ना? यहाँ पे है क्या लोडिंग? यहाँ पे वॉल है. I mean, there is a beam, but it is not subjected to BB masonry above it. Yes.
Yes, sir.
Then some of you may say that, sir, यहाँ पे भी ये विंडो है ना सर, ये यहाँ पे है, यहाँ पे डोर है, यहाँ पे डोर है, तो that is opening, no? Let's see. See, I'm giving you all these basic ideas, and I want to show that how approximate we are going for calculation of loads. See, actually, if this is internal wall, this is the door, yes or no? So
Yes.
this much loading, that which is actually not there, but you're going on higher side, yes or no? Hello?
Yes, sir.
sir.
And if you are having additional window over here, then this is also a void. It may be filled with frame and glass, etc. But that is the load is very minor, so you can neglect, or you can say that. So actually, this is the part that you are considering, where you may say that you are having BB masonry, yes or no?
Yes, sir.
Yes, sir.
But for calculation, we are not considering this. Then अगर आपको कंसिडर करना है तो क्या करना पड़ेगा? So find out the total area, okay, and find out the opening, and find out the percentage of opening, and you can apply that factor to this 9.31 multiplied by, let's say, total area of opening is 0.15, means area of BB masonry will be 0.85. So you may say that 0.85. And this value you can put in your calculation. Yes? Yes or no?
Yes, sir.
So this is one way. So अगर आपको बाल की खाल खींचने की आदत है तो you can go with this calculation, no problem. See, in engineering everything is correct and everything, at least in civil engineering, everything is correct and everything is right, wrong. It is as per your choice. So you may say that sir, ये ओपनिंग है, यहाँ पे विंडो है, बहुत बड़ा विंडो है, मान लो कि the window is having 2 meter width by 1.2 meter height. तो उसका जो ज्यादा है उसको क्या करें? यस, क्लियर है ना?
Yes, sir.
बट मान लो आपने ये बिल्डिंग बनाया, आपने क्लाइंट को दे दिया, अब ये क्लाइंट ने ये उसका फ्लैट किसी वजह से बेच दिया, और दूसरा आदमी आया और दूसरा आदमी ने ये विंडो निकाला और बोला मुझे यहाँ पे एडिशनल छज्जा चाहिए, उसने ये बना भी दिया। अब तब वो थोड़ी आने वाला है आपको पूछने के लिए, वो तो सीधा यहाँ पे ये बोल देगा प्रोजेक्शन डाल दो। ये पूरा वॉल उसने रिमूव किया और यहाँ पे उसने एक लिंटल बीम डाल दिया 7 फीट पे, और वहां से ये छज्जा निकाला। तो ये छज्जा का लोड कौन लेगा? See, I am giving you number of possibilities, and that's why we do not reduce weight of openings over here or here or here. Okay, हो सकता है ऐसा कुछ हुआ ना, तो जो ज्यादा लोड आने वाला है that we have already considered. So that's why 9.31. Again this is a thought, and there is always a dispute. Someone will say that that is the mistake or error that is carried by this person, so I am not responsible. But finally, if there is some accident, the people will suffer. So we have to take into consideration all possibilities. Clear?
Yes, sir.
Now here you can see, here you have considered a kitchen, and normally in Indian circumstances there is a way that we provide loft over here. Yes or no?
Yes, sir.
Yes, sir.
That is also not considered in drawing, क्योंकि आर्किटेक्ट ने आपको दिया नहीं, आपने उसको दिया नहीं, और बाद में वो बिल्डिंग बनाते समय जो भी क्लाइंट है वो बोला नहीं नहीं वहां पे एक लॉक तो होना चाहिए, हमारा किचन का मटेरियल जो है वो हम ऊपर रखेंगे, होता है कि नहीं होता है? तो
यस सर।
ये सारी जो अनिश्चितताएं है, अनसर्टेनिटीज in calculation of loading has been considered by IS code, and based on that they say that don't go for whatever loading that we are asking you, right? See, live load intensity, what live load intensity that you are providing over here per kilonewton, you are considering 3 kilonewton, or let's say in residential building you are considering 2 kilonewton per square meter, right? Yes.
Yes, sir.
Now this is 1 meter. So if you say how many people will be there? 1, 2, 3, 4. A normal weight of person, let us consider 80 kilonewton. So 80 into 4. How much it is coming out to be? 320. 320 kg. Okay. Hello.
Yes, sir.
So that
Yes,
means
sir.
it will be something around this 320 divided by 1000. So it is coming out to be 0.32 ton. So that means 3.2 kilonewton per square meter. Okay. So that is the maximum in 1 meter, but every meter will not be subjected. ऐसा नहीं होगा ना कि ऐसा हर ये रूम में इतनी सारी जगह है, तो दैट्स व्हाई ये सारा कैलकुलेशन करके कोड ने आपको दिया है 2 किलो न्यूटन पर स्क्वायर मीटर, दैट इज द मैक्सिमम कंसिडर्ड लाइव लोड. क्लियर?
Yes, sir.
तो ऐसा
Clear, sir.
see, I am saying just the various ways how they have found out. So ये सारी एक्सरसाइज कोड ने आपके लिए करी है, तो आप दोबारा वो एक्सरसाइज करेंगे या जो रेडीमेड और ऑथेंटिक इट हैज बीन ऑथराइज्ड? ऐसा नहीं है कि कोड में कोई लालू पंजू थे, वो उनके उनके जमाने के या आज के जमाने के एक्सपर्ट स्ट्रक्चर इंजीनियर्स हैविंग वेल वर्ड्स, और हो सकता है उनका 30-40 साल का 50 साल का एक्सपीरियंस है, और ऐसे 50 नॉट लेस देन 50 ऐसे एक्सपर्ट्स लोगों ने आपको वो IS 875 पार्ट 1 पार्ट 2 पार्ट 3 ऑथेंटिकेट करके दिया है. इट हैज बीन एक्सेप्टेड बाय एंटायर इंडियन कम्युनिटी. तो ये सारे देशों में होता है. अगर एसीआई इज ऑल्सो द सेम, अमेरिकन जो एक्सपर्ट्स है उन्होंने बनाया, इट हैज बीन प्रोवाइडेड टू एक्सपर्ट्स, उन्होंने उसके ऊपर अपने अपने कमेंट दिए. जैसे हम अभी कमेंट कर रहे हैं ना सर, 1 मीटर में ऐसा हो सकता है 80 किलो न्यूटन 80 केजी का आदमी, मगर हर आदमी 80 केजी का नहीं होता है ना, कोई 50 का होगा, कोई 80 का होगा, कोई 120. तो ये सारे वेरिएशंस को काउंट करके उन्होंने आपको कुछ फिगर्स दिए हैं. तो दोस फिगर्स आर रिलायबल, authenticated by experts, and it has been accepted for the entire India. तो वो फॉलो करना सबसे क्लियर है. तो that is why I am not reducing it. मगर फिर भी अगर किसी को लगता है नहीं नहीं मुझे रिड्यूस करना है तो वो कर सकता है. I just can't say that he is wrong. I will only say that under adverse condition, the structure designed by him might not perform satisfactorily. Wording में ध्यान दो. I am not saying वो गलत है. I am not saying correct है. What I am saying that under such circumstances, as he has not considered sufficient factor of safety due to condition, in that case, the building or the element may not perform satisfactorily. मैं ये भी नहीं कह रहा हूं कि कोलैप्स हो जाएगा. So failure does not mean collapse. Failure means not achieving the proper result. So हमारा proper result क्या है? What we are expecting from this slab, that whatever loading will be there, the slab will stand as it's like this, undeformed. ऐसा नहीं है कि लोडिंग ज्यादा होने के बाद ये स्लैब ऐसा हो जाए. Under engineering conditions, this is also called failure, though it is not collapsed, but it is a failure. And to avoid such things, every country is having a team of experts, and the expert with their study, they advise us for something, and that has been authenticated through their codal provision. So ACI is for America, IS for India, then maybe UK, they may be having BS standards, Euro standards in Europe. So every country, they are having their own standard based on their data. Clear?
Yes, sir.
Yes, sir.
So we'll go and apply the loading now. So now here I will select 1, 2, 3, 4 like this, or there is a shortcut. I will select, let me go to clear display. Yeah, select clear selection. Okay. So now I can select it like this. Because now there are no slabs available. Actually, they are there, but they are not visible. So I'm not selecting them. Yes. So I have selected, and I will apply loading. And what is that? 9.31. STL 9.31. Yes.
Yes, sir.
Yes, sir.
Apply close. So I'm not applying a loading over here because it is totally open, and it will not be whosoever may be there. Nobody will allow you to create a wall over here because it will obstruct your passage. Okay. So with that, I will go one step up. Then again, I will select, let's say, I'll select it like this. Like this. Now I am not selecting this. Yes, because they are carrying a wall of 1 meter and not wall of 2.55 meter. Clear?
Yes, sir.
Then go to assign, go to frame load, distributed, and under that 9.31, apply, and okay. Then I will select 1, 2, 3, 4, then 6, 8, 10, and 12 on one floor multiplied by 2 floors. 12 into 2, 24. So I have selected them correctly. And now I have to apply our load of 1 meter. Assuming that at balcony, I'm having height of wall as 1 meter. So now I can go to that assign, go to frame loads, distributed, and under that I will apply it. 0.15 multiplied by 1 meter comes out to be 3, and a plaster. So I will say that something around 4. Fine. Okay. Clear? Then I will go to plan, terrace, and at terrace, now I will select the only periphery. Right? And I can select this also, assuming that there is a 3-meter height. And now I will select this, and I will also select this. So it will have something around same. So no, in that case, no. This will not be. Yeah, only this much, because this much will have a height of 1 meter, right? So for this height of 1 meter, you can go assign frame load distributed, and under that distributed 4. So that is okay. Apply. Okay. And now I will select this. I will select this, and I will also select this, assuming that this is something around 2 meter high. Okay. So 4 into 2, 8. So I will go to assign into frame loads distributed, or you can go 9.31 also, but I will go for 8.0 and enter. So the loading has been applied to everything. Yes.
Yes, sir.
And then you can check it. How you will go to check it? Go to plan. Okay. Let us in plan will be over here. See, now I can check with A, B, C, D, E, F. Okay. So all that I can go to this, and I can see whether the loads are applied properly, and if something is missing, then you can apply by selecting that. Okay. So I have shown you that also. So I will just show you once. So if I see 2, so elevation 2, you can see at ground level there is no loading. At floor level, except the passage, everywhere you are having a loading. And at terrace, as this is a inner, so there is a loading at this only, in the passage only. So that means it is correct. Then if you want to see once more, let's say go to second, and if you want to see B, so B will give you a loading for this as well as this and this. And at terrace, you will find no loading over here. So you can go and see that elevation B. But actually, you should see each and every elevation, so that there will be no any negligence for loading. Okay, you can see 4 over here, 4 over here, 4 over here. So full load on the beams, and there is no loading over here. Clear? So you can check your entire model before analysis, because see, any software will not give you whether you have applied it correctly or not. So that's why it is you to check your model before going further, or check it from stage to stage, so that there will be minimum errors, or not errors, I will say that mistake. So by mistake, we might miss something, and that can be checked and get it corrected, and that's how you can go ahead. So select assign and clear display of assign, and then go to plan. Okay, now I want to show you one more thing. Now, see, you can imagine that in this wall, there is no slab over here at every floor because it is a duct. So there is a opening so that lift can move vertically up or down. Yes. Hello.
Yes, sir.
Now, if you want to, okay, let me clear display of a sign, select clear selection. Now, if you want to see that you want to draw the opening so that there will be no problem at all. So you can go to all story, and then you can go to draw. In draw, you can go to draw floor and wall object, and in this you can go to rectangular. Under rectangular, now here you can select the property as opening. See, some structure engineer use this facility so that they say that we don't want anything ambiguous. So everything must be crystal clear. So you can apply it. Or someone says that as I have not done anything over here, definitely there is a void. So I don't have to draw it. But it's again a question from one to one. So you can draw it like this. Okay. Now you can clearly see that there is opening. So everywhere there will be opening. So now you can go to your plinth level. Now at plinth, you can say you can keep it as it is, or you can remove, because in that case then someone will say that here also you should mark as opening. So that's why I will delete this. Okay. And if I go at foundation or base, here also I will delete it. And then you can go 1, 2. So this is your first. This is your first. You can see. So I have to go and check it, set display options, and then I will clear this floor. Now the floor will also be shown. Okay. So now you can check it. So this is what you will see your model correct. And then final stage you can do is go to analysis and check model and select all and click OK. Now it will see whether there are any drawing errors. Again, I am saying drawing errors. So model has been checked and no warning messages were generated. Now it is ready, and you can click on this and save it. Now what is left is go to define and load combination. So we'll do it, load combination, we'll do it in day after tomorrow session, and then they will analyze it and we'll see the results, and then we'll go for preparation for our lateral load. Clear?
Clear, sir.
तो यहाँ तक आपको मॉडल बनाना है. तो मेरे साथ आप रिजल्ट भी चेक कर सकते हैं आपके मॉडल पर. अदरवाइज आपको मेरे मॉडल से ही काम चलाना पड़ेगा. तो आप बनाएंगे?
Yes, sir.
ज्यादा ये मॉडल बनाने का ज्यादा टाइम आपको लगेगा आधा घंटा या 1 घंटा, प्रोवाइडेड you have gone through the sessions. You have आधा घंटा लगेगा। मैं तो कहूँगा ये 10 मिनट में मॉडल जनरेट होगा, पर ठीक है, इनिशियली आप आधा घंटा ले लो या 1 घंटा ले लो, बट डू इट सो दैट in next session when we'll be going for developing that, and we are going to develop all these combinations. These combinations are also very important. Let me show it where it is. Yeah. Okay, these combinations will go after we will apply earthquake in X direction, earthquake in Y direction, and dynamic earthquake in X direction and dynamic earthquake in Y direction. But before that, we'll analyze it for these two load cases, because all other cases are including lateral loads. And as we have not done anything with lateral loads, these combinations does not hold good, because there is no lateral load, right? But we'll after this analysis, we'll go for earthquake in X direction, Y direction, spectra in X direction, spectra in Y direction, and then all these combinations. Clear? तो मॉडल आपने अगर बनाया तो आपके लिए एडेड एडवांटेज है, अदरवाइज यू कैन डू इट एज पर योर टाइम अवेलेबिलिटी. Okay, so do you have anybody having any queries with whatever we have done today? Yes.
Sir, can you please show me this elevation in C or D after loading?
Which one? This C
C, yes.
and D.
Yes, sir.
Okay, it's very simple. You can go to elevation and you can click on D, C, and you can see. Okay, so go to display. Okay, display and load assign, and under that frame, and under frame I will go for STL and I will say okay. Clear?
Okay, sir.
Similarly, you can go to D, elevation, select D.
Sir, in that we have a load applied on this frame 1, 2, 1, 2. So we have any roof for that area, for the stair area? We will do it later, or we just...
Yeah. Actually, see, we are going through this, but actually, yeah, whatever you are saying is correct. Let me show it. See, actually, here we are considering, but actually this one will be covered by terrace top, staircase top, and this one will be covered by lift machine top, right?
Okay, sir.
Yeah, that you can do it. Can go to edit storage data, get system data in this, and here you can right click and you can add story with keep existing story height. Okay, you will add one story over here, because story height now here you can say that you don't need 3 meter, so 2.4 something around 8 feet, that means 2.4. So you can say 2.4 is the story height. Number of stories added are 1, and it is added over terrace 1, and you can click OK. Now this you can change it to lift machine. So I will say overhead water tank, OHWT, and and lift machine. So LIFT M/C. Whatever name that you want to give, you can give the name and you can say okay. You can say okay. And now if you go for your elevation C, see now it has been added, this forehead. Now here you will remove that loading because it was duplicated as a terrace, and then you can go to plan overhead water tank and that, and all these entire things you can delete. Let me show you. Clear display of a sign. Now this is one story. So I will select 1, 2, 3, 4, 5. So I will delete it like this. Then I will delete it like this. Okay, you can see 1, 2, 3, 4, 5, 6. I can delete it. Then I can delete this also. I can delete this also. And I can delete this also. So now you can see that this is your water tank or a staircase top, and this is your lift machine top. And now this also you can delete, and you can create a slab over here. And now if you see this elevation, you will find that it is right. So that you can do that later on. So don't worry about it. Right now, understanding the basic things is very important. Or you can check it over here. Okay, let me show you that 3D. Now you can see that. Exactly, this is what you wanted to see. Yes.
Yes, sir.
So that is not at all a difficult task. You can create by replication. You can create n number of stories right now. As I have shown you, you can apply one story. You can say instead of one, you can say 10. Then it will show you 10-story structure plus whatever is 5 below. So 15-story structure. So that is not a big task. Don't worry about it. वो water tank का क्या होगा, वो lift machine का क्या होगा, वो ऊपर का अगर कुछ है तो क्या होगा, वो सब आसान हो सकता है provided you know the basics. नॉर्मली क्या होता है कि हमें ऐसा लगता है कि जितना हमने सीखा ना उतना ही है. ऐसा नहीं है. एवरीथिंग यू कैन डू एवरीथिंग. You can change everything. You can change the grid system also. You can change the properties also. You can change the sizing of columns also. You can change the you can delete some column. You can add some column. सब कुछ उसमें हो सकता है प्रोवाइडेड पहले आपको बेसिक तो आना चाहिए ना. Right? See, right now my job is to prepare you in the basics. मुझे पता है कि अगर आपको ये बेसिक सही ढंग से आने लगा ना तो आई नो दैट you will do all other advanced concept. You can just go in this help and you can see that how it can be applied. So don't worry about water tank, then stair, what is the stair, incline stair and that. वो सब हो सकता है. See, you are missing जो जो हमने यूट्यूब पर वो आपको अट्रैक्ट करे, होता ना वो जादू जादू, जादू दिखाता है, अरे कैसे करे बनाया, अच्छा बनाया। We are not here to see the magic. We are here to see the basics. ऐसे नहीं, हम तो 5 मिनट में आपको ये सारा बना के देंगे, वो आपको ऐसा लगेगा अरे को तो सब कुछ आता है। वो तो वो जादू जैसा हो गया। दैट सी यू मस्ट अंडरस्टैंड व्हाट see my aim is that when you are drawing one column you must understand what this software has done behind your screen. उसने क्या क्या बनाया है, उसके स्टोरेज में क्या क्या है, उसने पॉइंट बनाया है, उसने लेंथ बनाया है, उसने साइज रखा है, उसके लिए उसने एड्रेस दिया है, वो एड्रेस में उसने वो सारी चीजें रखी है, और जब भी आपको चाहिए वो वहां से दे देगा। द मोमेंट यू आर ड्राइंग अ बीम, यू आर ड्राइंग points automatically. The moment you are drawing a beam, you are applying the local axis as well as global axis automatically without your knowing. मैं चाहता हूं कि आपको वो सारी चीजें अगर समझ आए ना, तो you can find out the errors and you can correct the model, or you can find out what should be the corrective measures that you should apply so that you get the desired results. Getting the desired result is the important. Clear?
Yes, sir.
Yeah. और ये आपको कहीं नहीं मिलेगा। सो मैं हूं या अनिल सर है, हम लोगों का वो कोशिश रहती है कि आपको इनबिल्ट में क्या हो रहा है, हाउ दिस सॉफ्टवेयर इज गिविंग यू द आंसर दैट यू वांट। सॉफ्टवेयर ने तो अपने आप कुछ नहीं किया, तो किसी ने उसको वो प्रोग्रामिंग दिया है, तो वो प्रोग्रामिंग में उसने क्या क्या दिया है। So there we are concentrating. That's why we are focusing on basic things. Local axis क्या है, plane of plane क्या है, results कैसे है, और results में shear क्या है, bending क्या है, torsion क्या है, वो वैसा ही क्यों है। अगर वो पता चला ना, तो that is the best thing that you should know. फिर थोड़ा सा अगर आप कंटिन्यूअस ये मॉडलिंग में 3-4 साल फॉलो करेंगे और सोचेंगे, तो आपको भी वो आएगा। मगर नहीं सोचेंगे ना, तो यू विल बिकम अ मैकेनिक। पता नहीं है, मतलब यू आर ड्राइविंग अ कार बट यू डोंट नो हाउ इट इज गेटिंग स्पीड अप। आपको इतना ही पता चलता है गियर डाला तो ये स्पीड से जाती है, ब्रेक लगाया तो यहाँ तक रुकती है। क्यों रुकती है? ऐसी क्या खूबी है वो गाड़ी में कि उसको पता चलता है कि आपको ब्रेक लगाना है। गाड़ी तो मशीन है ना, तो कैसे पता चलता है? अगर आपको मैकेनिक्स मालूम है तो आपको पता, ओ सिंपल है, जैसे आप क्लच दबाते हो या ब्रेक दबाते हो, तो इनबिल्ट जो मैकेनिकल सिस्टम है उसमें ये सारी चीजें होती है, उसकी वजह से गाड़ी का स्पीड कम होता है। तो this is also a machine, and that you must understand why he is showing you this color. Can you ask him to show another color which you like? Okay, any other query? थोड़ा ज्यादा नहीं होता है ना? नहीं, क्या होता है? यस, हेलो, ऑनेस्टली बताना। यस, समी, अभिषेक या केतन,
नो सर।
कुछ ज्यादा हो रहा है क्या? या
No,
No, sir. No, sir.
ये
Perfect.
वो जानना जरूरी है या नहीं है?
जरूरी है सर।
yes sir.
Okay, so then I am with you, and okay, next session
Excuse me,
will
sir.
yeah,
So I have a doubt, sir. जब हम कॉलम जैसे आपने बताया था कि ओरिएंटेशन हम डिसाइड करते हैं, तो सर मेरा ये डाउट था, जैसे सर अगर कॉलम की जो शेप है, जैसे अभी हमने रेक्टेंगल ली अगर कभी सर्कुलर लेनी होगी तो उस केस में आर्किटेक्ट वो डिसाइड करे सर्कुलर लेनी है, या फिर वो हम स्ट्रक्चरल इंजीनियर डिसाइड करेगा कि शेप क्या होगी इस तरीके से?
नहीं नहीं नहीं, वो इन दैट केस अगर बिल्डिंग के आर्किटेक्चरल गेटअप की बात है तो वो आर्किटेक्ट डिसाइड करता है। आपको क्या करना है कि अगर उसने 300 डाया का कॉलम लिया है तो आपको चेक करना है कि वो 300 डाया सफिशिएंट है या यू नीड मोर और इट कैन बी लेसर देन 300।
यस सर,
एंड
वो
व्हाट शुड
कोड
बी
में
द
वो दे रखा था कि
रिइंफोर्समेंट।
जैसे 1.05 टाइम्स, मतलब वो 5% ज्यादा लोड लेते हैं सर्कुलर केस में, तो इसलिए पूछ रहा था कि स्ट्रक्चर का रोल है या फिर आर्किटेक्चरल पॉइंट ऑफ
नहीं
व्यू से।
नहीं नहीं नहीं, वो शेप का आर्किटेक्चरल है और डायमीटर एंड कंक्रीट एंड उसके अंदर जो रिइंफोर्समेंट है that that is to be decided, or that decision is to be taken by structure engineer.
ओके ओके।
See, many times what happens, architect may need say a 9 meter circular column and without any cross ties, क्योंकि वो उसको अच्छा दिखता है ना। वो
यस
इंस्टीट्यूट्स में होता है, देखो ग्राउंड फ्लोर से सीधा थर्ड फ्लोर तक, सो 9 मीटर वो विदाउट एनी lateral ties. Normally what we are doing, we are applying a lateral beams connecting column at every floor level, right?
यस यस।
But sometimes there is a architectural requirement that they say that our view is getting disturbed, so we do not want a tie beam over here. So in that case, he will say that a shape should be circular and you will decide what should be the diameter.
ओके सर,
Yeah.
थैंक यू सर।
Yeah. Okay, anybody else having any query? ठीक, अगर कुछ भी डाउट मन में है तो मुझे पूछ सकते हो। अगर मुझे पता है तो मैं हाँ बोलूंगा, नहीं तो मैं बोलूंगा मुझे उसका पता नहीं है। मैं कोई वेग आंसर नहीं दूंगा, कोई फेक आंसर नहीं दूंगा। एंड आई डोंट वांट माई सेल्फ टू बी ओवर स्मार्ट। मैं ऑनेस्टली बोल दूंगा, भैया ये मुझे पता नहीं है, मुझे देखना पड़ेगा। आई माइट कम विथ आंसर आफ्टर few days, so don't worry about it. So you can ask me any query, but if you are asking the queries with relevant with whatever discussions that we are carrying right now, that will be better. But that doesn't mean that you should not ask any other query regarding structure, which is we are not discussing right now over here. You can ask me, जैसे जैसे अभी समीर ने पूछा, या केतन ने पूछा शायद। यस,
मैंने पूछा था सर।
हाँ समीर या समीर ने पूछा था। तो ठीक है ना, उसको उसको वो जो डाउट था उसने पूछा। अगर वो डाउट का आंसर है मेरे पास तो मैं बताऊंगा, अगर नहीं है तो मैं कहूंगा थोड़ी 2 3 4 दिन बाद देखेंगे। बट यू कैन आस्क। यस अभिषेक, आज बहुत शांत है, क्या हुआ?
सर दिक्कत ये है कि अभी तो लास्ट की 2 क्लास सर मैंने करी नहीं है, तो इसलिए डाउट का अभी नहीं है सर।
ओके, तो रिकॉर्डेड सेशन देख लो ना भैया।
यस सर।
या और ऐसा कुछ खास नहीं, मैंने पहले भी कवर किया था। द ओनली थिंग दैट all that information whatever we have carried in previous 5 sessions, we have applied that in the last 2 sessions,
Yes, sir.
but with practical model. Baki, but it's good to if you go through the session recorded sessions which you have missed. और फिर भी अगर कोई क्वेश्चन है पूछ सकते हैं, ऐसा नहीं है कि आई एम नॉट सेइंग दैट as you have missed the 2 sessions, you are not authorized to ask me. No,
No, sir.
don't worry
अभी
about
तो
this.
ऐसी
Is
कोई
not a
डाउट नहीं है
class. We are friends.
यस सर, बिल्कुल सर।
Yes, am I audible?
Yes, sir.
Hello.
Yes, sir.
Yes, sir.
So,
You are audible.
yeah. So it's my request to all of you. So we are not here to criticize anybody. We are not here. We are here to learn and help each one. आप लोग आपस में भी वो कोई ग्रुप जैसा बना के आपस में डिस्कस कर सकते हैं, या आप में से कुछ लोग अगर बोलना नहीं चाहते तो दे कैन पास ऑन द मैसेज टू समीर, अभिषेक एंड केतन. दे विल आस्क मी, डोंट वरी अबाउट इट. कैसे मेरा मेरा फोकस इसी पर रहेगा कि आपके दिमाग में कम से कम डाउट हो, यानी डाउट्स है उनको मैं ढंग से उसका आंसर दे पाऊँ.
एक्चुअली सर दिक्कत अभी थोड़ा इसलिए आ रही है क्योंकि हमारा सा बेसिक क्लियर नहीं है ना, तो सर उसका अभी गो थ्रू हो रहे हैं तो वो अच्छा लग रहा है मतलब.
या फिर भी हम आपके लिए वो अभी वो आपको एक 8-10 दिन के अंदर पता चलेगा कि हम लोग आपके लिए शनि इतवार को एक सेशन
Yes, sir.
क्रिएट कर रहे हैं जहाँ पे मैं और अनिल सर दोनों रहेंगे. एंड यू पीपल आस्क द क्वेरीज फॉर दैट यू आर फेसिंग, और द ट्रबल दैट यू आर फेसिंग, और डाउट यू आर फेसिंग, or anything you want to know, and we'll discuss on that. So there will be
बिल्कुल sir.
no agenda from our side. Agenda will be set from you people.
Yes, sir.
तो ज्यादा अच्छा रहेगा. तो वहां पे हम आप लोगों के लिए कुछ रिकमेंडेशन भी देंगे कि आपको ये किताब पढ़ना जरूरी है. तो यू कैन स्टार्ट विद दैट. विल मेक इट अवेलेबल. एंड okay, I think for this P+5 or G+5 practical problem, we have given you architectural data, GA drawing, as well as input DBR. Everything we have given it on classroom. Yes or no? आप लोगों ने आपको मिला कि नहीं?
Yes, sir.
Yes, sir.
या तो उसको डाउनलोड कर लो, और डाउनलोड करके उसका फायदा ले लो, क्योंकि वो बहुत सिंपल तरीके से और सिस्टमैटिक मैनर से हमने बनाया, जो अगर आप डिसिप्लिन के हिसाब से आप अगर उसको यूटिलाइज करने लगे तो डेफिनेटली यू विल हैव अ कटिंग एज ओवर द पीपल और ओवर योर फ्रेंड्स और कलीग्स. क्योंकि ये इस ढंग से आपको कहीं पर नहीं मिलेगा. उतना तो हम प्राउडली कह सकते हैं, मैं एज वेल एज अनिल सर, उतना तो हम डेफिनेटली कह सकते हैं, क्योंकि हम लोग ये सारी चीजों से गए हैं. बराबर है ना अभिषेक?
बिल्कुल सर.
सिस्टमेटिकली नहीं मिलेगा. हाँ मिलेगा, क्योंकि हम लोगों ने भी कहीं ना कहीं से लेके एक्सट्रैक्ट करके आपके लिए बनाया है. तो डेफिनेटली आपको भी उधर मिलेगा, मगर वो पता आपको अंडर वन अम्ब्रेला ये हम लोग दे रहे हैं, तो उसका ज्यादा फायदा लो. मेरा कहने का मतलब है, व्हेन वी आर गिविंग इट, वी एक्सपेक्ट यू टू टेक द एडवांटेज.
Yes, sir.
Yeah.
Definitely.
Yeah, definitely. Okay. So with this, we'll conclude today's session, and in next session, we'll start with results and load combinations, and then we'll shift to earthquake analysis.
Yes, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Good night,
Good night, sir.
Yeah, good night. Good night.
Thank you, sir.
Yeah, thank you.
Good night, sir.
शहाजी पाटील काहीतरी पाहिजे नाही. ओके.